in Biology 2:11, we looked at some general things, you know, like different systems and stuff. But today we're going to look at chapter 15, and we're going to look at the heart and the cardiovascular system. Now, the first thing that I want to call to your attention on page 556 in your book. Let me show you this. I'm losing the papers. I've got papers all over in here. But this is the diagram. We're gonna talk about it here for a second. This diagram will definitely be on your test. Probably be a matching type format. But I want to show you this because if you've got your book, take a look at this. When we draw a picture of the heart and we look at the parts of the heart, we have to also say that what's the purpose of the cardiovascular system? The purpose of the cardiovascular system is not only to pump blood throughout the body, but it's to reoxygenate that blood. So we've got to, with every breath in, and every beat of the heart, we have to synchronize this so that we take the oxygen in and the carbon dioxide out. So if we get off on that, and we start breathing, we're not a regular breathing, that's called hyperventilating, where we get too much oxygen in or too much carbon dioxide out. So this is that's hyperventilating. So what happens if somebody's hyperventilating? You probably heard this before. Now this won't be on your test as such, but you take a paper sack and you put it over. Why is that? Because what you're breathing out is carbon dioxide, and if you're breathing out more carbon dioxide, and you need to breathe in more, that's what the sac does. It allows more of that carbon dioxide to come back in. So once again, it's all about balance. It's all about equilibrium. It's all about trying to get it to where we have an equal amount of oxygen in, an equal amount of carbon dioxide out. So when we look at this, we have the parts of the heart. Once again, if you have it, you're fixing to go through and answer all of the practice questions in the chapter. And that's a big thing. I stress that over and over because we're not going to cover everything in the whole chapter for your test. We're just going to hit some highlights. There's some things in the standards that we have to know, but in terms of what you need to know everything in this chapter. I mean, I would hate for you to be in the medical profession, and if you're in the medical profession, your degree will allow you to take some of the other courses that will expand on these things. But this particular diagram, when we look at the heart, we also look at where the lungs are at. We also look. It's interesting. We talk about systemic capillaries above and below the heart, where we have a transfer of oxygen and carbon dioxide. So this is a big thing. The blood is actually. People are like, well, does the heart pump blood directly into the lungs? And the answer is kind of interesting because we actually have a series of systemic capillaries that actually exchange the carbon dioxide and the oxygen. So really an interesting system. So when we memorize and look at the parts of the heart, we also include the systemic capillaries, top and bottom, and we also include the lungs. And so really interesting. So take a look at that diagram, study it pretty good for your test. It'll be a big part of your test. So once again, a lot of the questions that we're going to discuss today, you may have had under your practice questions. We're going to expand on some of them, and so it's going to seem kind of random today. It's going to seem kind of random, like we're talking about one thing and then something else. So what we're going to do is we're going to go over. This really is a plus. Once again, I don't want to. The information I'm about to give you will all be on your test. The diagram, everything I'm going to talk to you today is going to be on your test. And but I don't want to make it about the test. I want to make it about you understanding the heart and the cardiovascular system. So here we go. The membrane closest to the heart muscle. Okay, the membrane closest to the heart muscle. Now, you're going to see a lot of times where the area that contains the heart. Once again, the heart is a muscle. Okay, we know the heart is muscle tissue. Now, so when we talk about muscle tissue and the membrane that encloses that's called the pericardium. Okay, pericardium. So pericardium. And cardium, the Latin word in there, cardio, is to pump, okay? And so this is where we get the heart to contract, to pump, the cardiovascular system, okay? The cardiovascular system. The pericardium, para means to surround, cardio means the pump, okay, or the heart. But there's a lot of pericardiums, but the membrane closest to the heart muscle, okay? So we have the outside pericardium, and then we have another layer that's protecting the heart. Then we have another layer that kind of protects the electrical part of the heart. But then we have a lining, and we have a pericardium that's the closest to the heart muscle. That's called the visceral pericardium. So V-I-S-C-E-R-A-L, visceral, V-I-S-C-E-R-A-L, pericardium, P-E-R-I-C-A-R-D-I-U-M. So that's the membrane closest to the heart muscle, is the visceral pericardium. Now, when we say what is the prominent symptom of pericarditis, okay, P-E-R-I-C-A-R-D-I-T-I-S. Now, whenever you hear, once again, we're trying to put some Latin words together here, okay? So para meaning around, cardio meaning the pump or the heart, and then itis. Now, whenever we see, we talk about bronchitis, we talk about all kinds of, the prefix itis on the end means that we have an abnormal situation. Something's not working right. Itis. Okay? So let's think about this. It says, what's the prominent symptom of pericarditis? All right? And the answer to that is severe chest pain. So when the heart is not working, okay, and we have pericarditis, okay, then we have severe chest pain. Now, why is that? Why do we have this severe chest pain? We have this severe chest pain because we have this muscle that's trying to work. And when the right amount of blood comes in, okay, when the right amount of blood comes into the heart, okay, and the right amount of blood goes out, then whenever the muscle contracts, okay, it's sending the right amount of blood out of the heart, and then whenever it relaxes, it's bringing in the right amount of blood into the heart. But what if we have, for whatever reason, okay, whether it's coronary heart disease, whether it's the heart's at the wrong rhythm, whether or not we have another problem within our body, okay, what if whenever I contract, that blood doesn't come out, and then whenever I open this up, okay, and the blood didn't come out, if I leave blood in there, then I've got too much blood in there, okay? So now the next time I try to push that blood out, all of a sudden I've got too much blood. Or what if all the blood comes out, and then as it comes in, I don't get blood back in, the heart is still trying to, it's relaxing, letting that blood in, but it's still squeezing, trying to get that blood out. If there's no blood in there, then our heart begins to work as a muscle. And it can't work, so it works harder, it works stronger, and it contracts tighter, and lo and behold, that's our severe chest pain. Okay? So, once again, this is pericarditis, severe chest pain. All right, now, what part of the heart is usually damaged by scarlet fever or syphilis? Okay, now why mention these two? Because we have to talk about, there's a certain area of our heart, and let me give you the answer, and then we'll come back and talk about it. The part of the heart that's damaged by scarlet fever or syphilis is the endocardium. Now, once again, if you understand Latin, you can really understand human anatomy, okay? Because once again, endo means the inside, the very interior, the middle of, okay? In there where all these chambers are. Cardia, meaning the pump, okay? So the endocardium is the endo muscles all around the heart. So it says that it's damaged by scarlet fever or syphilis. Oh, that's terrible. That's a bad thing, because the endocardium is where the actual atriums and ventricles are for our heart. So which part of the heart is damaged by scarlet fever or syphilis? That's the endocardium. Now let's talk about, I'm not going to go through, you've already had this. If you haven't already done your practice questions in your book, you're going to go through how all the blood travels through the heart. You know, whether it's right atrium, left ventricle, or whatever. So I'm going to cover a few of these things as we go here. the atria, okay, so you have the right atrium and the left atrium, okay, the atria will empty during, all right? Now, we're going to see a couple different words, diastole and systole. So we have the diastolic pressure and the systolic pressure. So one of them is blood coming into the heart, and another one is blood going out of the heart, okay? So let's think about this. So the atria will empty during. Well, let's think, is that diastolic or systolic? Well, it's systolic since it's emptying, okay? And so where is that at? It's kind of interesting because the atria will empty during atrial, A-T-R-I-A-L, systole, S-Y-S-T-O-L-E. So once again, what does this mean? Okay, whenever we say atria systole, systole means we're emptying the heart. So the answer to that question is actually in the question. The atria will empty during atrial systole. All right, now the first heart sound resulting. So if I have a stethoscope and I'm listening, what's the first heart sound? We talk about this, and we say the heart actually says a thump, thump, thump. It's actually a kerplunk, kerplunk, because we actually hear something first, and then we hear the blood flow. So here's the thing: it's kind of cool, and the more you use a stethoscope, and if you have the opportunity to do that, you'll get really good at that. Okay, the first heart sound results when the AV valve closes. So we have an AV valve that actually shuts off. Okay, so we don't hear the heart relax and the blood comes in, and then boom, we shut that valve, because then the heart's gonna, after we shut that valve, and the heart's let the blood in and it shuts this valve, the AV valve, okay, we hear the AV valve close, and then we hear the bloop. And what that is because then the heart contracts and pushes that blood out. So the first sound is the AV valve closing. All right, now, a stethoscope placed at the tip of the sternum, okay, once again, sternum is a breastbone, will best be able to detect which sound, okay? So now we're talking about the heart is directly behind the sternum, okay? So we're talking about the sounds we hear with the stethoscope, and why is this important? It's important to understand the heart, but it's also important to know the sounds that we're listening for as a medical person to know which things are working correctly. Like, for example, that first sound is that AV valve. I know it's working if I hear it go and then the heart. Well, this says a stethoscope placed on the tip, okay, on the tip of the sternum, okay, will best be able to detect what sound, and it's the tricuspid valve. Okay, so when we're looking at our diagram, we see that tricuspid valve right in the middle of the heart, and that's the sound that we would hear if the stethoscope is placed at the tip of the sternum. We hear the tricuspid valve. Okay, now which chamber of the heart contains the pacemaker? Now, once again, some people have an artificial pacemaker, all right, but we have a natural pacemaker telling our heart what pace to go, and the pacemaker is contained in the right atrium. The right atrium literally has an electrical system. We're powered by 0.5 millivolts in our body. We have to have that. And that literally shocks based on that pacemaker's firing of the heart. And what happens when we shock the heart? The heart contracts. Okay? When we don't shock the heart, what does it do? It relaxes. So when it contracts, blood out. Whenever it relaxes, blood in. Okay. Now, the pacemaker is one of those things that if somebody has an artificial pacemaker put in, it's kind of interesting because then we can't control. Our pacemaker controls the amount of metabolism in our body. So when we're sleeping, the pacemaker goes way down and our heart slows down. But whenever we're running and exercising, then our heart speeds up and our pacemaker allows that to go faster. The problem with a traditional pacemaker, and I'm sure through the years we'll develop a pacemaker that's adjusted to our metabolism, but the problem is that pacemaker goes at the same pace. So somebody that gets a new pacemaker, and once again, I may even be behind on my technology. I'm sure they're out there, but a basic pacemaker today, unless it's a specialized metabolic one, goes at the same pace all the time. So when you're sleeping, your heart rate is actually faster. But when you're trying to work out or do something, your heart rate's actually slower. So kind of interesting on a pacemaker.